Hey everybody, how's it going? Mr. Reeves with you again today. And today we're looking at proportions. So in this first video, we're going to be looking at if a pair of ratios actually forms a proportion, then solving proportions. And then in the next video, we're going to do some word problems involving proportional relationships. All right, so let's talk about this idea of what a proportion is. Hopefully you got a chance to watch the Khan Academy videos and do some practice on Khan Academy. But even if you did, it's always good to review. So what is a proportion? Well, we've talked about what a ratio is. A ratio is a comparison of two quantities, or a comparison of two quantities by division, we often say. And we've talked about what equivalent ratios are. Equivalent ratios are ratios that can simplify down to the same ratio. They are equivalent or they are equal to each other. They have the same value. All right, so a proportion is simply two equivalent ratios set equal to each other, or a ratio equal to an equivalent ratio. So when you are asked in 8th grade skill H8 on IXL, do the ratios form a proportion? The question could be phrased, are they equivalent? Which of course is something that you have already done. So this is kind of just a repeat of what you were doing when you were asked if they are equivalent. So the question is, does 1/2 equal 5/16? Are they equivalent? All right, now this one should be pretty obvious just by logical reasoning, right? 1/2 means the top number has to be half of the bottom number, or the bottom number has to be twice as big as the top number. All right, and clearly 5 is not half of 16, right? Or 16 is not twice of 5. All right, we would know that if we wanted 1/2, if the top number were 5, the bottom number would be 10, right? Or if we wanted it to equal 1/2 and the bottom number were 16, then the top number would have to be 8, right? So this one is no. Another way we can look at this, we remember equivalent ratios must simplify to the same ratio. And 5/16 doesn't simplify. There are no common factors. All right, and then another way you can check is, you remember I showed you that cross multiplication way. If I multiply across here, 1 times 16 is 16, right? And if I multiply across this way, 5 times 2 is 10. And 10 is not equal to 16. Remember, if those are equivalent, or now we're going to start saying if it is a proportion, then those cross products must be equal. And 10 is clearly not equal to 16. So this one, for many, many, many reasons, is no. All right, what about this next one? 3/4 and 12/16. So again, we want to know, does 3/4 equal 12/16? Is this a proportion? All right, well, if I take 12/16 and I factor out the common factor of 4, what do I get? I get 3/4, and 3/4 is definitely equivalent to 3/4. They are equal. So this one is yes, right? If we took a look here, we could say to get from there to there, I can multiply by 4, right? And from there to there, I can multiply by 4. And since both the numerator and the denominator are multiplied by 4, they are equivalent ratios, right? I could also change these to decimals. 3 divided by 4 is 0.75. And if you did 12 divided by 16, guess what you would get? 0.75. There's so many ways that you can investigate these ratios. It's kind of fun. And of course, let's not forget that cross product. If I did this one, right, this is 4 times 12, which is 48. And this one right here, what do we have? 3 times 16, which is also 48. And since 48 is equal to 48, the cross product check proves that this is a proportion. All right. Okay, let's see if they got anything a little more difficult for us up at the next level. All right. Okay, so now they've changed it. They're not writing it as a fraction. They're writing it using the colon 2. So I'm just going to say that 3 to 9 can be written as 3 to 9, right? And 2 to 6 can be written as 2 to 6, okay? Remember, a fraction is just a different way to write a ratio. And the question is, are those two the same? All right, so let me ask you, could you simplify these? Could you simplify these? Well, 2 6, I could divide both of these by 2, could I not? Right? And 2 divided by 2 is 1, and 6 divided by 2 is 3. So 2 6 simplifies to 1/3. And 3 ninths, well, I can't divide backwards now, can I? Divide by 3, divide by 3. 3 divided by 3 is 1, and 9 divided by 3 is 3. So since both of them simplify to 1/3, that does prove that they form a proportion, right? Again, dividing down this way, you would see that they both simplify to 1/3. If you were to make them decimals, they would both be the decimal of 0.3 repeating, right? And of course, our cross product check, 9 times 2 is 18, and 3 times 6 is 18. Don't you just love proportions? Oh my goodness, I love proportions. Okay, 1/4 and 6/24. Guys, I hope you can see very quickly, being the advanced math students that you are, 6 over 24 is going to simplify to 1/4, right? So that one is a yes. All right. Do they have anything any more challenging for us? 1/10 and 5/6. All right. 1/10 and 5/6. Now, let's take a quick look here. All right. Most of you are probably going, obviously it's no. All right. 1/10 is definitely much smaller than 5/6, right? But if I went like this, that's 1 times 5. And if I did that, 10 times 5 is not 6, is it? If I did 10 times 5, this should be 50. So if they were going to be equivalent to 1/10, that would have to be 50, right? And it's clearly not 50. If we did our cross product, 10 times 5 is 50 here. 1 times 6 is 6, and 6 does not equal 50. So this one is not even close to being a proportion. Alrighty, how about, let's see here, the challenge zone. 20 over 15 and 16 over 12. 20 over 15 and 16 over 12. The question is, do they form a proportion? All right, so I'm looking at both of these, and I'm saying I can simplify them, can't I? All right, 20 over 15. I can divide both of those by 5. Can I not? And 20 divided by 5 is 4, and 15 divided by 5 is 3. So this simplifies to 4/3. And what about 16 over 12? Well, those are divisible by 4. 16 divided by 4 is 4. 12 divided by 4 is 3. And they both simplify to 4/3. They are equivalent ratios. Therefore, they form a proportion, right? We could do the cross product. Here's an example of where doing the cross product really is not something we want to do, especially if we don't have a calculator, because it's going to take us more time than it's worth. Simplifying is a much faster way to prove these ratios are equivalent, which means they do form a proportion. All right, I think you guys have the idea now, if you didn't already have it, on how to do those to check if two ratios are equivalent and therefore form a proportion. All right, what about solving proportions? Moving on to skill H10. Now, what they're doing is they're saying it's a proportion. So they're saying 12 over 6 is actually equal to 4 over C, and they want us to find C. We're going to find C, okay? So if you understood what we were just doing, then this is going to be not too bad at all. Okay, so they have to be equivalent ratios. So the question is, what's the relationship between the first number to the, all right, let's call these, because I wrote them as fractions, I'm going to call this the numerator. All right, if they were written with colon, it'd be the first quantity, right? What is the relationship between the two first quantities? And that relationship has to be the same. And by relationship, I mean by multiplication or division. Well, to get from 12 to 4, I divide by 3. 4 is 1/3 of 12, right? Or if I wanted to go the other way, if you prefer multiplication, you could say 4 times 3 is 12. So either way, this first numerator here is 3 times as large as this one. So therefore, this one must be 3 times as large. So I like to, when we're going from bigger to smaller, to use division, because then I can just divide. So 12 divided by 3 is 4. 6 divided by 3 is 2. So that's one way to look at it. Probably an easier way is, instead of looking across, let's look up and down, right? And again, this is why proportions are so great, because you have so many different ways to get the answer. 12 is twice of 6. The numerator is twice as big as the denominator, right? So in this case, the numerator must be twice as big as the denominator. Or again, if we're going the other direction, the denominator is half as big. I divide by 2, so the answer that I get is 2 that way, right? And finally, if you need another way to do it, remember that cross multiplication check method we had? All right, if we multiply across, what do we get? We get 12 times C equals 4 times 6. Well, 4 times 6 is 24. So I get 12C is 24, and I divide both sides by 12. I know we haven't done equation solving this year, but you should be familiar with basic equation solving like this, and I get C is 2. So all those different ways to get the answer that C is equal to 2. All right? Okay, what about this one right here? We have 8 over 12 equals 12 over J. Okay, now again, many different ways we can look at this. Now you'll notice that 8 does not go evenly into 12. So in a case like this, when they give you a ratio that is not simplified, many times a good strategy is to simplify that ratio. Well, 8 over 12, I can divide both of those by 4, correct? And 8 divided by 4 is 2. And 12 divided by 4 is 3. So I get 2/3 equals 8/12. So I can actually replace that 8/12 with 2/3. If you're going, wait, you're allowed to do that? Yes, because they are equivalent. All right, and why do I like this better? All right, because now I can say, okay, 2 goes into 12 6 times, right? So if this second numerator is 6 times that first one, then this one also must be 6 times as well. And I get 12 over 18, right? So the answer I'm looking for is 18. Just a quick check, if I did 12 divided by 18, if I divided both of those by the greatest common factor of 6, what would I end up with? 2/3. So 8/12 and 12/18 are equivalent to 2/3. So the denominator I'm looking for is 18. All right, so there's some other ways you can do this. Again, many times you will see people do the cross multiplication method. I think I mentioned in a previous video, I'm not a huge fan of this because it does not require any understanding of proportional reasoning. It's just kind of an algorithm you learn. But if the goal is to find what makes it true, learning an algorithm can help you out. So I do 144 divided by 8, which turns out to be 18. So, but I'm going to recommend if the ratio you are given, the entire ratio you're given can be simplified, simplify it first, okay? And then that will usually make solving it much easier and faster. So I'm going to go ahead and type that answer of 18 in, and I'm going to skip up to the next level. Okay, 2 over f equals 186 over 465. I guess this is supposed to be more difficult because the numbers are bigger, but honestly, this one's easier in my opinion because 2 goes evenly into 186, doesn't it? All right. So if I can say 186 divided by 2, what is that answer? Well, 2 goes into 18 9 times, and 2 goes. So this is times 93, right? I guess, again, the number is not a friendly number, right? You don't know your 93 times tables. But I know that this second number is 93 times as big, right? Or if I'm going the other direction, I could divide, since that's the one I don't know, I can divide both of these by 93, right? So I need to do 465 divided by 93, right? I'm thinking it's going to be 5, right? Because 5 times 100 would be 500. 5 times 3 is 15. Carry the 1. There we go. All right. So the answer is 5, 2/5, right? If we divided both of those by 93, we would get 2 over 5. All right. So I really don't think that one was all that bad at all. Ooh, 75. Oh, decimals. Oh, yeah. Gotta love it. 3.1 over 3. You mean proportions? Ratios can have decimals? Imagine that. Okay. All right, but this isn't bad at all because if you look here, hopefully you can see that 3.1 times 4 is 12.4, right? 3 times 4 is 12. 0.1 times 4 is 0.4. So that simply means the bottom number is times 4 as well. Easy peasy lemon squeezy, right? The answer is 12. The answer is 12. There we go. All right. Can we get up to the challenge zone? Here we go. Oh my goodness. This really is a challenge zone. Okay, guys. We're going to have some algebra going on here that you may not be all that familiar with. Remember, you only have to get up to a score of 80. So if this algebra is something you are unfamiliar with, no worries. No worries. All right, so let's take a look here. What makes this more challenging? Well, it's not just g, it's g plus 4. So let's look at this a couple different ways. First of all, 2 over 4 simplifies to 1/2. Do you guys agree? Right? 2 over 4 simplifies to 1/2. So what does that mean? That means the bottom number is twice as big as the top number. Are you following with me? The bottom number is twice as big as the top number. So let me ask you, if the bottom number is 12, what would the top number have to be? It would have to be 6, right? So 1/2 is equal to 2/4, which is equal to 6/12. But they told us that the top number is g plus 4. So something plus 4 has to equal 6. Right? So what is that something? That is 2. 2 plus 4 is 6. So the answer is 2. All right. Let's look at the algorithm way. All right. If you just want to do some number crunching, some algebra without thinking, which I don't like. All right. I guess there is some thinking involved. Many times you will see people go directly to this. They're going to cross multiply. Okay, this requires a little more algebra skills going on. All right, 2 times 12 would be 24. So that cross product is 24. This one is going to be 4 times g plus 4. And again, I don't really like this because we haven't done our algebra yet this year. All right, but I would use something called the distributive property that you may or may not be familiar with. And I'd get 4g plus 16 is 24. And then I would subtract 16 from both sides, okay? And then I would get 4g is equal to 8. And then I would divide by 4, and I would get g is equal to 2. So if you're like an algebra guru as a 7th grader, you could do it that way. What I like about this way, realizing that the top number is half of the bottom number, or the bottom number is twice as big, it's using proportional reasoning. And using proportional reasoning, I think you can get to the answer actually easier than this algorithm method. All right, but either way, the answer is 2. All right, let me do one more of those, and then we're going to call it a day on these videos. Actually, not call it a day. We're going to call it a video because we still have the other video coming up after this. All right, so again, this time a little more complicated because instead of just having a variable for what's missing, I have an expression. All right, but again, I'm going to recommend that you take that 4 over 6 and you simplify it to 2 over 3, right? What did I do? I divided both of these by 2. So if I do that, why is that better? Okay? Because now 2 doesn't go into 3 evenly, right? So last time we looked at the relationship on the top and bottom. But remember, with proportions, you could look at relationships going up and down. You could also look at relationships going left and right, right? Do you agree that 9 is 3 times as big as 3? If you don't, I'm sorry, you're wrong. 9 is 3 times as big as 3. So this must also be 3 times as big. All right? So what does it have to be? Well, 2 times 3 is 6, right? So we know that 6 over 9 is what it has to be because it has to be 3 times as big on the top and the bottom if they're going to be equivalent ratios. So j plus 4 has to equal 6. Hey, that sounds familiar. J is equal to 2. Didn't we just have an answer of 2? All right, I guess they're keeping the numbers nice and small to be nice to us. All right, so you get the idea. I hope this is helpful for you. And as always, if you need any more help, you can always shoot me an email. And whoops, I didn't mean to do that. All right, this is what I meant to do. I'll see you next time.